In the final video for today, we're going to again make use of our graphing calculators to run some sort of polynomial regression to find a polynomial function that describes each of these sets of data. Now, in order to do that, we've got to determine which polynomial regression we want to run, because if we take a quick look at our calculator and we go to the regression menu, so we hit Stat, go over to Calculate. We've done linear regression, we've done quadratic regression. There's also a cubic regression, which would be a third-degree polynomial, and a quartic regression, which would be a fourth-degree polynomial. Unfortunately, the calculator does not have capabilities to do anything higher than a quartic regression. So to determine which regression we want to run, the first thing we want to do is determine which set of differences ends up being constant. For example, when we find the first sets of differences, for example, -7 minus -1 is -6, -3 minus -7 is 4, 5 minus -3 is 8. 11 minus 5 is 6. 9 minus 11 is -2. And -7 minus 9 is -16. Now, we don't have a constant set of differences yet. So we are going to do the same thing. So that's the first set of differences. Now we're going to find a second set of differences. 4 minus -6 is 10. 8 minus 4 is 4. 6 minus 8 is -2. -2 minus 6 is -8. And -16 minus -2 is -14. We still don't have a constant set of differences yet. Oh, let's do purple next. Where we have 4 minus 10 is -6. -2 minus 4, also -6. -8 minus -2 is -6. And -14 minus -8 is also -6. So it is this third set of differences that is constant, which means the polynomial which describes this set of data is a third-degree polynomial or a cubic. Think back to a couple of videos ago, we call a third-degree polynomial a cubic. So we're going to run cubic regression when we are ready. Now, in order to run regression, we are going to go to our lists. And if you have anything in your lists, to clear those out, you up arrow so the heading is highlighted, and then hit clear, enter. And the same thing for list 1. Clear, and then enter. So what we're going to do now is just enter this data, and I'm going to enter it with the keypad. So it goes a little bit quicker. There we go, so we're all set. So I'm going to enter the x-coordinates in list 1 and the y-coordinates in list 2. And the x-coordinates are -3. Oh, it's not going to let me do that negative. So I guess I have to do it on the calculator itself. So it'll take a little bit of extra time. That's okay. So I'll go ahead and clear. So I've got -3, -2, -1, 0, 1, 2, and 3. Okay, so those are all the x-coordinates, and then in list 2 I'm going to enter the y-coordinates, which are -1, -7. I should hit enter after -1, and then -7, -3, and 5, 11, 9, and -7. So again, since our third set of differences were constant, we're going to run cubic regression for a third-degree polynomial. So we're going to go to Stat, right arrow to the regression menu, and to calculate, and cubic regression is number 6. So we want to do it to list 1, list 2. Since we're not making any predictions, we don't have to worry about storing the equation anywhere. So we're just going to go ahead and calculate. So you'll notice that cubic regression is of the form y equals ax cubed plus bx squared plus cx plus d, where a is -1, b is also -1, c is 8, and d is 5. So our equation that describes that data is y equals -1x cubed minus 1x squared plus 8x plus 5. That is the polynomial that describes that data. Now, similarly, in the second set, again, we need to determine what regression we're going to run. Doing that by determining what set of differences ends up being constant. So in the first one's -16 minus 23, that is -39. -15 minus -16 is 1. -10 minus -15 is 5. -13 minus -10 is -3. -12 minus -13 is 1. And 29 minus -12 is 31. Well, that one obviously is not constant, so we're going to find the second set of differences, where we take 1 minus -39, that is 40. 5 minus 1 is 4. -3 minus 5 is -8. 1 minus -3 is 4. And 31 minus 1 is 30. So, on to our third set of differences. 4 minus 40 is -36. -8 minus 4 is -12. 4 minus -8 is +12, and 30 minus 4 is 26. Haha. You probably caught this. 29 minus -12 is 41. Hello? So that makes 40 here. My bad. And then makes this difference 36. So then, with our fourth set of differences, -12 minus -36 is 24. 12 minus -12, 24. 36 minus 12, also 24. So it's the fourth set of differences that are constant, which means the polynomial that describes this data is a fourth-degree polynomial, or a quartic. So then, to find that quartic, we go to our lists, Stat, and Edit. And the x-coordinates are exactly the same that we did for part A, so we don't need to change that. What we do need to change are the y values. So we'll enter 23, negative 16, negative 15. I forgot to hit enter. So negative 16 for the second one, then negative 15, then negative 10, then negative 13, negative 12, and then 29. And then we're going to run that fourth degree regression, which is quartic regression, under the stat, and then right arrow to calculate. And quartic regression is number 7. And we're just going to hit enter until we calculate it. So for this one, A is 1. So we have x to the 4th. B is 0, so we have no x cubed term. C is negative 5, so we have minus 5x squared, plus x, and then minus 10. So writing that one, our quartic model, y equals 1x to the 4th minus 5x squared, keeping in mind that b was 0, plus x minus 10. And that is the quartic model for that data. So to determine which regression you run, you find which level of differences are constant. And as I've proven, please be careful with the subtraction. That was a pretty good cool check on my part. So that is finding a polynomial function that describes a given set of data.